sections are leading towards the last section, which is solving linear equations using matrices, solving simultaneous linear equations. So today is the first piece that we will use in that sort of larger scale process, and it's known as the determinant. So the determinant is, it's just a value that you get from a matrix. So you can get the determinant of all sorts of different matrices. The one that we're going to focus on is a 2x2 because that's what we need in order to do the simultaneous equations later. So determinant of a 2x2 matrix, so randomly just assigned A, B, C, D. You write it as A with two straight lines on it. That means determinant. Or sometimes you'll see it written with DET and then the matrix name. Or sometimes you'll see it written with the matrix and then two straight lines around the entire matrix. That's all the same thing. It's three different ways that you can say, find the determinant of. And the way you actually do it is really quite simple and straightforward. You do AD, multiply those together, and then subtract from that BC. So you're multiplying the diagonals and then subtracting them. So that will generate the determinant of a matrix. So for example, we have a matrix here, 1, 3, 2, -1. The two straight lines on either side indicate that we want to find the determinant of this. So the determinant of this would be A times D, which gives me, maybe I'll write the whole thing out for this first example. So we do 1 times -1 minus 3 times 2. So that gives me -1 minus 6. So -7. So the determinant of this matrix is -7. So again, right now, that number doesn't mean a whole lot to you. It will in the second half of this lesson, and it definitely will in a couple of classes. So the second example here, we're finding the determinant of A if A is this. So again, we're going to do A times D, so 2 times -3, subtracting from that -2 times -1. So we're getting -6 minus 2, or -8. So the determinant of that matrix is -8. So in terms of calculator section, non-calculator section, you can find the determinant of a 2x2 matrix without using a calculator. You cannot find the determinant of, say, a larger matrix by hand, or at least we're not going to do that this year. So I just want to quickly show you how to find the determinant on your calculator. So we'll do this example here that we just did. So turn it on. So again, I'm just going to clear that. So again, to do everything with matrices, you need to start in that matrix menu. So second x to the power of -1 to get into the matrix menu. First thing I want to do is I want to edit a matrix. So it is a 2x2 matrix, so that's fine. So we've got 2, -1. Careful to use your negative button and not your minus button. -1 and -3. Okay, so then once you've entered in all the values of your matrix, you're going to get out of that menu entirely, just to start fresh. And then to find the determinant, you're going to go back into your matrix menu. And this time you're going to go to math, because we want to do some math calculations with this matrix. So you'll see the first option there is determinant. So I'm going to select that one. And then it pulls me back to this screen. And then the only other thing I have to do is enter which matrix I want to find the determinant of. So back into your matrix menu, and this time I want to use the names menu, and I want to use that first option. I want to find the determinant of matrix A, or at least what I've called A. So you'll see that the determinant opened a bracket. If I was going to do more calculations, it would be important to close that bracket. Since I'm not, it's not as crucial. You can if you want to, but you don't have to. It's not going to change your answer. And then I get an answer of -8. So again, you can use your calculator to check if it's in a calculator section. If it's in a calculator section, you can just use your calculator right off the bat. If it's in a non-calculator section, you cannot use your calculator at all. Okay, so let's move on to the second part of this lesson, which is going to be to use the determinant for something that's kind of interesting. So we can use the determinant to find the area of a triangle if we're given the coordinates of that triangle. So I've got this triangle drawn on a set of axes. Here's one crucially important point. One vertex must be at the origin. If it is not, you must make some adjustments, and we'll do an example like that after. But one point must be on the origin. Then the coordinates of the other 2 points, arbitrarily for simplicity's sake right now, are just AB for this point and CD for that point. So to find the area of a triangle, here's the formula using a matrix and coordinates. So it's 1/2. That should seem pretty familiar to you. And then we've got these 2 straight lines and then this matrix set up. So the numbers from the matrix come from the coordinates of the other 2 vertices. Remember, the 3rd vertex is your origin, so it's at 0, 0. So whatever the coordinates of point A are, one of the other points of the triangle, you're going to put those 2 numbers in on the top of your matrix. Whatever the coordinates of B are, you're going to put those 2 numbers in as the bottom of your matrix, and then you're going to have 2 straight lines on either side. This first straight line, this outer pair of straight lines, is the modulus, also known as the absolute value. So the very last step you're going to do is, if this determinant ends up being negative, you're going to take the absolute value of that, which means take off the negatives, and then you'll do 1/2 of whatever that number is. And then the inner 2 straight lines is your determinant. So again, AD minus BC. So let's go through a couple of examples. All right, so first one is find the area of the triangle with vertices 0, 0, 5, 11, negative 2, 7. So one of my vertices is the origin, so that's good. I don't need to do any adjusting for that. So I can head right into my formula. So area equals 1/2, 2 straight lines, and now I set up my matrix with one of my coordinates as my top 2 numbers, and the other coordinates as my bottom 2 numbers, 2 straight lines. So now I've got 1/2, so the first thing I'm going to do is figure out the determinant. I'm going to leave this absolute value line because I haven't quite done that yet, and then I'm going to do AD, which gives me 35, minus BC, which gives me negative 22. Keep my absolute value for the moment. 1/2 of 35 minus negative 22. Oh, forgot a bracket there. It gives me 1/2 of 57. If I take the absolute value of 57, it is still just 57. So if I do 1/2 of 57, then I get 28.5, and I don't have anything else except units, and I'm squaring them because this is area. Okay, so that's how that one works. So let's get to a slightly more complicated example where we do not have one of our points at the origin or at 0, 0. So when that is the case, you need to adjust your coordinates. You need to adjust one of them so that it is now on the origin, and then the other 2 get adjusted in the exact same way. So it's almost like we're picking up the triangle, we're moving it so that one of the coordinates is now on the origin, and then because we're moving the whole triangle, the other 2 points will move accordingly as well. So it makes the most sense to choose the easiest one or the smallest numbers to kind of translate. So if I move that one to 0, 0, what I have done to the x coordinate is I've subtracted 2. What I've done to the y coordinate is I've subtracted 3. So I've got to do the same thing to all the others. So x coordinates get subtracted 2 from them. And then my y coordinates, I have to subtract 3 from them. So now when I do my area formula, those are the coordinates I'm going to use now. All right, so area is 1/2 of one coordinate on top, one coordinate on the bottom. So I've got 1/2 of the absolute value. So the determinant is going to be AD multiplied together minus BC multiplied together. So I've got 1/2 of the absolute value, 16 minus 32, that gives me -16. So now when I take the absolute value of that, I get 1/2 times +16. So my area is equal to 8 units squared. So that's one example of what you can use the determinant for. Again, we're gearing up for that simultaneous equations section in section F, but that does it for section D.